Problem 3-52. Consider the sequence 10, 2, etc., etc. Assuming that the sequence is arithmetic, with t of 1 as the first term, write the next 4 terms of the sequence and then write an equation for t of n. So, starting out with part A, we're going to be looking at the arithmetic sequence. We already know that our sequence starts with 10, and then our second term is 2, so I'm going to go ahead and fill these in. I'm using a table. I know many of the students in my class use a table. You can use a table if it helps it to be more familiar to you so that you can get the equation correctly. So we start out, we got 10, 2. Since it's arithmetic, we have to look at how is this growing? What's the pattern here? Arithmetic, we know, is going to have a constant growth here. We're saying what happens from 10 to 2, or in this case it's decreasing here. A lot of people want to say we're either subtracting 8 or adding a negative 8. Either is fine in this case here. Say, okay, we are subtracting 8. So we want to continue that pattern here. So our third term would be the result of taking away 8 from 2. So 2 minus 8 would be a negative 6. And then we take away 8 more, we're going to be at negative 14. Take away 8 more, we're going to be at negative 22, and then we're going to be at negative 30. I'm going to go ahead and fill those in up here on my sequence. I have 10, 2, third term is negative 6, fourth term is negative 14, fifth term is negative 22, and my sixth term is negative 30. So we've satisfied the next 4 terms that it was asking us for, and now we need to come up with the explicit equation for t of n. So remember, t of n is going to be the output of our function. So we have t of n here. These are all of the terms in our sequence. N, remember, is our term number. Our first term was 10, but in order to come up with the explicit equation, we need to go backwards to figure out what our 0th term would be. That would be our starting point here. So, if we're subtracting 8 each time here, and if we went backwards, we would have to add 8. So, if we add 8 to 10, we should be at 18. Think about that. 18 minus 8 gives us 10. 18 minus 8 minus 8, or minus 8 twice, would give us 2. 18 minus 8 3 times would give us negative 6. So our 0th term was 18. Our generator is going to be subtracting 8, or plus a negative 8. So which of those is happening repeatedly? Well, 18 only shows up once. It's just our starting point, and we're taking away 8 over and over again. So the way you show that you're subtracting 8 again and again would be like saying minus 8 n number of times. So our sequence explicit equation would be t of n equals our starting point at 18 minus 8 n number of times. To check it, we could go ahead and plug in any input value or any term number in our sequence to see what term we would get. So let's say we wanted to see what our 5th term would be. We'd take it and we'd say the 5th term of the sequence is going to equal 18 minus 8 5 times, which is, remember, going to be our 5th term here. So let's see what happens. 18 minus 8, well, 8 times 5 is going to be 40, so 18 minus 40 gives us negative 22, and we know that our 5th term of our sequence is negative 22, which is right over here. So we know that our explicit equation is correct. Part B asks us, assuming that the sequence is geometric with t of 1 as the first term, write the next 4 terms of the sequence and then write an equation for t of n. So, got that one already set up here. So our first term, remember, is 10. Our second term is 2. So if you would like to use a table, go ahead and use a table. If you don't want to use a table and you feel like you're more comfortable writing it out, go ahead and do that. Either way, remember a geometric sequence, we're looking for the common ratio, or what number here we have to multiply 10 by to get to 2. A lot of people say, oh, well, we're dividing by 5. That is correct. However, we want to be able to show it in our equation as multiplication. So remember, dividing by 5 is the same thing as multiplying by 1/5. If I do 10 times 1/5, I get 2. And if I do 2 times 1/5, I'm going to get 2/5. And we would continue that pattern here to come up with the rest of the terms in the sequence. 2/5 times 1/5 would be 2 20/5. So you may finish filling out the table if you like. I'm going to go ahead and put my terms into my sequence up here. So I had 10, 2, 2/5 was my third term. My fourth term was 2 20/5. Okay, my fifth term in the sequence, I take 2 20/5 and I multiply it by 1/5, and I'm going to end up with 2 125ths. I multiply that times 1/5, I'm going to end up with 2 625ths. So, to come up with our explicit equation here, once again, the same exact thing is going to happen. We need to figure out our 0th term, which remember is not actually a term in the sequence, it's just a number that we use to come up with the explicit equation. In order to come up with it, we have to go backwards. The opposite of dividing by 5 would be multiplying by 5, or dividing by 1/5 there. When we do that with 10, 10 times 5 is going to end up giving us 50. So our 0th term ends up being 50, and that's where I would start. Then you have to ask yourself, how are we getting from each term to term? Well, 50 times 1/5 is going to give us 10. 50 times 1/5 times 1/5 would give us 2. 50 times 1/5 times 1/5 times 1/5 would give us 2/5. I think you get what I'm saying here. So if we take 50 and we multiply it times 1/5, and we're doing that n number of times. This is where you have to be careful. Remember, to show that you're multiplying by the same number repeatedly there, you have to take it and you have to take 1/5 and raise it to the nth power. It's not 1/5 times n, it's 1/5 raised to the nth power. This is exponential decay in this case. Okay, exponential growth and decay requires an exponential type of function here. Our sequence here, t of n equals 50 times 1/5 raised to the nth power, is exponential growth. Or an exponential equation there. So that's one thing you have to remember. Geometric sequences have exponential equations. For part C, it's asking you to create your own sequence. I'm going to allow you to do that there. You don't need me to do that for you. So hopefully this has helped you with parts A and B of problem 3-52. Good luck.